Hey guys, so today we'll be looking at one of the most sought after, most popularly used application of OpenCV, and we'll see how to turn it into a web application as well, right? So these are the contents of today. So we'll be going into a brief overview like what is facial emotion recognition, then why is it needed, its applications, and then how to perform it, right? And then we'll look at something called Flask. It is a web framework which allows you to deploy your application onto the web so that your clients can use it, right? And then we'll see how to do that. And then we'll see something called Heroku, what it is, why do we need it for our application, and how to do it, right? So let's jump in. So yeah, what is facial emotion recognition? It's simple. You can just understand it from the name. Facial emotion recognition is technology that analyzes facial expressions and landmarks and classifies them into emotions to give you information about the subject's emotional state, right? So, yeah, happy, sad, angry. So, there are 6 basic classes. We'll see what they are further. Now, why do we need facial emotion recognition, and what are its applications? So, in general, in real life, also facial emotions are very important for communication, right? They are known as non-verbal communication cues. I've mentioned that here. As the name suggests, they're very important in a conversation to understand what the speaker is trying to say and in what context he's saying what he's saying, right? So basically, FER does just that. It extracts and analyzes information from an image or a video, and then it will give you a classification of which emotion it might fall into, right? So here I've mentioned a few applications. These are the broad fields like personalized services and healthcare, education, crime detection, public safety, and there are so many other fields that it can be used in. This is just a broad to give you a broad idea, right? So here I mentioned music recommendations, interactive marketing and advertising. So see, in cases like this, it helps to improve the business, right? So you'll be delivering a more personal, customer-based product. So it's very useful in spaces like that. And then in healthcare, to detect autism or depression, it's very important to understand emotions in such cases, right? To to understand the facial expressions. So, and then observing patients and their condition during treatment, and then you can use that to treat them better, right? And then education, obviously, to monitor students' attention, then to give a more effective tutoring. So if you see that all the students are, dull and not engaged, then you can do something to, make it more interactive, make it more interesting to them. So it'll improve the quality of learning. Similarly, in public safety, you can have usually um, facial emotions are very important while solving crimes and stuff like that when you have to find the uh, you know accused. So so it'll be used it's widely used in detecting frauds or to predict if there's going to be a potential terrorist activity in some area, or especially this, you can detect if the driver is feeling sleepy or that driver is bored. So then it would prevent a lot of accidents, right? So it's very useful in cases like that. Now, how to perform this? So there's a basic algorithm that every facial emotion recognition follows. So the algorithm has 3 major parts. The first part is obviously face detection. So it has to look at the frame, an image or a video, and it has to be able to detect the faces in that frame, right? So that is the first step. Then the second step would be facial landmark detection. Landmarks are like the coordinates of the eyes or the coordinates of the nose or major coordinates on the face. So that would be your landmarks. So the algorithm should be able to detect these landmarks to be able to understand if there are any changes in those. So it can later analyze those changes and then come to a conclusion of classifying it into an emotional class. Right? So that is the second step, and the third step would be classification. Like I said, it has to classify the changes into the emotion classes. So here I've mentioned six basic categories of emotions: anger, disgust, fear, joy, sadness, and surprise, and happiness, obviously. So these are the six basic ones. So any usually most facial recognition applications, they follow these six, but you can make them further deeper, I would say, like joy and sadness, joy and surprise. So you can do that as well with a little more tweaking. So but these are the six basic ones, and most applications will show you only these six ones, right? Now, how to implement this algorithm in your computer? There are three basic ways you can do this. There's an OpenCV library which you can use. It's the simplest, very less code. Then you can use a pre-trained model. So there are, since like I've said, it's one of the most sought after applications today. So there are many people who have built models on facial emotion recognition. So you can use those pre-trained models. Either you can use them directly, like you can download the model and you can directly use it on your new data set, or tweak the model a little bit. You can download the model and train it on a separate database, a more personalized database, right? And that's called transfer learning. So this is what I've mentioned here, transfer learning. So either you can use the direct models of the internet, or you can download these models of the internet and modify them by training them through according to your dataset. So that's the second part. And then the third one is you can build a model from scratch and train it on your dataset, right? So you can build either a CNN or an RNN, and then and then you can train it on your data set, so it will give you a more personalized model, so it will work best for your use. So we'll be going with this one. So I'll be using an OpenCV library, easy to understand. Okay, so let's jump to, yeah, this is the code. Now I'll jump to VS Code. Yeah. So as I've mentioned, we'll be using an inbuilt library called emotion recognition. We won't be importing the whole library. We'll just import a small module. Along with that, obviously CV2 library needs to be imported. Then we'll initialize these variables. So er.variable will be later used to call a function from the imported library. And cam is to initialize the device's camera. Okay, then we'll move on to the while loop and we'll read the frame and store it. Now we'll use the er variable to call the recognize emotion function from the emotion recognition library. So it takes the frame as one of its parameters and a return type. So the return type can be grayscale or RGB. Here I'll be using BGR because we need the BGR image. So what this recognize emotion function does is it follows the basic algorithm. It detects the face first, then it identifies landmarks and classifies them into emotions, right? But after that is done, it also takes care of drawing a bounding rectangle around the detected face, and it will print the uh, classified, it'll print the name of the class that the image is classified into on the bounding rectangle, so that you can see on the frame itself which class, which emotion class it was classified into. So it returns the input image along with the bounding rectangle of the face and the text of which class it belongs to this variable. So we don't have to do the additional task of, drawing the bounding rectangle and then outputting the frame. This function takes care of that. So we can directly output the frame and then we'll release the camera and destroy all windows. Okay, so we'll run the code. Okay. Now we can move on to the rest. Yeah. Now we'll see how to integrate this code that we wrote into the web. Okay. So for that we'll be using this tool called Flask. So now what is Flask? Flask is a web development framework for Python, specifically for Python. So it makes a developer's work a lot easier. You wouldn't need a separate web development team who would integrate your code into the web. You can simply just use Flask. So it makes it a lot easier without having to worry about details like protocol management and thread management and all that. Now, why do we need Flask in our project? Like I mentioned, we need to deploy it on the web, but we don't have a full-fledged web development team, so we can just use Flask to do that. So, but why do we need to deploy it on the web, right? So once you build a model, it needs to be used. Suppose, say for example, you're you're a developer and your customer is a bank, and you need to build a model which predicts whether the bank can approve loan to their customer or not. Uh, so far you've done all your work, you've built a model that takes in features like salary, dependents, loan amounts and all that, and it will predict whether to give the loan like as a yes or no question. But once you build the model, you need to give this model to the bank employees so that you can use your model, right? So instead of taking this model and putting it on their servers, which probably might not be supported to use Python or its libraries, or it needs a lot of space. Usually CNNs um, run a lot. They take up a lot of space and they take time to run. They need special GPUs and all of that. Instead of all that, you can just deploy your model onto the web and they'll be able to use the web. So in the web page, they just have to go to this link that we give them, and then they'll be able to enter in these features, and the model will predict and it will show the output on the web page itself. So they don't have to worry about deploying this model and how to use this model and all that. It'll be very simple, user friendly. So this is why we'll be using Flask. So in our project, we'll be using Flask to show this in real time. Like we'll be using it to predict which emotion is being shown on the camera. You can also integrate it in such a way that it takes in photographs and predicts the emotion in those photographs. So that will be the image part of it. We are showing the video part of it. Now, how to integrate it is it have three main files, right? There's a camera.py file, there's an app.py file, and then there's a template folder. So this templates folder, it holds the basic HTML, like the structure of your web page, where should be the nav bar, where should be your icons. all that is handled by the templates folder. So let's go ahead and see that. Before that, this is what our final web page would look like. So we have a nav bar, we have a heading, we have an icon here, then we have a little text here, we have a background. That all of that is handled by the templates folder and the HTML files. This part is handled by the camera.py and the app.py files. So here is another one. Anyways, let's jump into the code. So this is mainly what runs our web page. So we will be using these modules. We'll be using these modules from the Flask library. So we'll import those. Then we'll be using something called video from our camera module. So this camera module is nothing, just this what we have written here is the camera module. So the camera module, it does this main part of reading and recognizing and all of that is done in this part. Okay, so as usual, we'll import the libraries and initialize the variables. Then we'll have an init function which initializes the camera, and we'll have a del function which releases the camera. Then we'll have a getFrame function which reads the camera and classifies it into emotion classes and then returns this frame as a JPG in the form of bytes. So this code does that. So in the main.py file, what we've done is we'd run this and we'd simply outputted the frame, right? But here what we're going to do is we'll encode it into JPG format and return the JPG format in the form of bytes to be able to display it on the HTML. So here we'll be initializing the Flask module first to a variable, and then we'll route. So the app jumps to this part, okay, and it goes into the function index, which jumps to the index HTML. Okay, so this index HTML has a line which connects it to the base HTML. So once it reads this line, it jumps to the base HTML and it constructs your web page. So all this is basically constructing a web page. Here's the text that we need and the icons, everything. Okay, after that, it will go on here and it will go to this part. So it will go to the video part. So the video part is where we come over here. So app route to video. It jumps here and then it executes this function. So what this function does is it returns a response. So it calls this main video function which we saw in camera. So when you call this function, this will be executed. So the camera will be initialized, okay, and then it jumps back. Once that's done, it'll go back to generating a camera, because till now we have completed only this part, right? So now it'll jump back to this part and it'll start executing from here. So it'll execute this function. What it does, it runs it in a while loop. We have a while loop. We'll read the frame and it will go to get frame. That is this function. So it then reads the frame, then does the classification, then encodes it into JPG and sends it back in bytes. So this frame variable holds the JPG format in the form of bytes. So when we use yield, it's basically reconstructing the JPG form to be able to display it on the index HTML. On the final web page. So after that, now this code is already executed, right? So it will jump here and it'll run the app. So we'll do the same. We'll run our app and check what's happening. So once you close your web page, this part of your code will be executed and the video camera of your device will be released. Okay. So apart from this, there's one more thing I want to mention to all of you. So here there's a warning. So it says this is a development server. Do not use it in a production deployment. So what this means is that whatever you've done so far, your Flask app is only on the developer server. So you can't give this link that we followed to your client and say that he can use the model, right? So unless he runs this app.py along with all these pages, he won't be able to use this link to get to the web page, actual functioning web page. So to do that, to be able to give him a link which he can use to go to the model and use the model, we need to use another tool called Heroku. So yeah. Now, what is Heroku? Here it's mentioned it is a container based cloud platform as a service. So, it offers a service. It is a it is a cloud platform which turns your Flask apps into fully functioning web pages. So, at the end of your deployment on Heroku, what happens is it gives you a link which you can give it to your client, and your client can use that link to access this web page, and it will do the facial emotion recognition. But one thing about Heroku is that you can't deploy real time in it, so you'll have to use static images. So you have to tweak your code a little instead of starting your video camera and releasing your video camera. You should read an image from the local files and give it to the model. A little bit of a change you have to do for your deployment on Heroku. So now I'll show you how you can tweak your code a little to be able to deploy it on Heroku. So let's jump into VS Code. So first we'll check out the main code. So you know the libraries, and then this we've seen earlier. Here we won't be initializing the camera variable because here we don't need to use the device's camera. We can just use cv2.imread to walk to the directory in which your image is, and we'll read that image and store it in frame. So here I have my image in the same directory, so I specify the path, and it'll be read into this variable. So like before, again we'll be using the recognize emotion function to determine which emotion is being shown in the picture, right? And then finally we'll display the frame. So we'll see how that works. There. So it's able to detect. Now we'll go back and we'll see what changes to make to app.py. So what we've seen earlier is that we need a camera.py file along with the app.py file to be able to control the device's camera. But here, since we won't be using the device's camera at all, we won't be needing the camera.py file at all. What we'll be needing here is another library along with this one to be able to identify and go to the right path in the directory to be able to retrieve the image from that path, right? So let's see how that works. So here I've done some initializations. I've just specified the paths. Now, here you'll be able to understand this part is basically us allowing the web page to be able to go to a specific folder in your directory and to be able to retrieve the image. Okay, so what our web page would look like is that it will have an choose the file button for the user to be able to choose a file from his local device, and an upload button. So now when the user uploads an image from his local device, it will get saved in the uploads folder. Okay, so this code is to be able to retrieve the image from the uploads folder. So once you go through this, you'll be able to understand that. Okay. Now the main part of emotion detection, it happens in this function, detect underscore object. Okay. So this we've seen earlier, right? We've seen this, and then this is basically from the main.py file. We'll recognize one additional uh, thing that this detect object function does is, after detecting the emotion on the image, what it does, it writes the output image to the downloads file, so that the web page will be able to access this downloads file to be able to display the output image on the web page. Okay. So here, once we, this is error handling basically. So if there isn't a file, or there's a file that doesn't match these formats, so in cases like that, this code will be able to handle that, right? So once everything is fine, like the image is fine, the format, everything is fine, it comes here, it will save the file in the upload folder, right? And then it will process the file. So it jumps to the process file function, which in turn jumps to the detect object function, comes here, and it detects the emotion and it writes it to the download folder. Okay. After that, this data is stored here, like I said, in the uploaded image in the uploads folder, and the detected output frame in the downloads folder. Now what will happen is, in index.html, the rest, everything will be same as usual before what we had. There'll be a little tweaking here and there because we need to add two buttons. This is to load the file, load the path, and this is to upload the file, right? So this is the buttons and their HTML code to be able to display these buttons on the web page. Now here, this is where the processed image function comes in, right? So here, from here, the web page calls the function, and the function will in turn call the detect object function, and then it'll go on from there, right? And once it's detected, it will be written to the downloads folder, which is again then displayed over here. So this is what is happening. Now we'll see how this code works. Okay. So we'll follow this link. And so here you can see a choose file option where you need to select the path, and then after selecting the path, you'll have to upload. Let's go and do that. And then upload. So this is the output frame that will be displayed on the screen. Okay. Now we got the Flask app running, right? The next thing we need to do is, you need to make sure you have, first of all, you need to make sure you have these folders there, right? The uploads and the downloads folder. Apart from that, you need to make sure that you have these three files: a proc file, a requirements.txt file, and a runtime.txt file. Now what these are, I will tell you. So the runtime.txt file, it tells Heroku which version of Python to use to be able to execute it and deploy it on the web, right? So now there are only a few versions of Python are supported by Heroku. Like for example, here 3.6.7 is the version that I need to be able to run this code. But 3.6.7 is not supported by Heroku. What you need to do is you need to change this to a version that is supported by Heroku. Now, where to find these versions? You can go onto Google and the official Heroku website. There they have mentioned the supported versions of Python. So you need to use one that is a little higher than yours, so all your functionalities will be executed without any issue. Okay, so that's about runtime. Now about requirements. So here all the dependencies that you need to be able to execute your file will be recorded here. Now suppose you don't know all the dependencies or you want to check which ones are important. What you can do is you can go to the terminal. Let me go to the new terminal and you can type pip, sorry, yeah, you can type pip freeze greater than requirements.txt. So this will generate all the dependencies that are required for your app to run. Now there are a lot of extra dependencies for my app because my runtime environment is linked to Anaconda. Needn't, it's not necessary that your requirements will be as many. Usually there'll be a lot less, right? So you don't, there are a lot of unrequired requirements over here because my environment is linked to Anaconda, but usually they're very less. So for your, when you do pip freeze greater than requirements.txt, you might get a lot less number of requirements and dependencies, right? Now the third one is the proc file. So you need to this is the only thing that you need to mention over here: web colon unicorn app colon app, right? So this is specifying that it is a web application. Okay, so that is important. So one thing that is very important that you need to keep in mind while you're checking your requirements is that it needs to have a Flask dependency, because obviously yours is a Flask, so mine's over here. And then you need to make sure that there's a unicorn dependency, this one. These are the two main important ones, so you need to make sure these are there in the requirements.txt, right? So now once you have all these ready and in the same directory, you can upload this onto your GitHub. Okay, so I will show you that. So here's my GitHub and I have all these files over here. Okay, so there's a proc file, there's an app.py file, and there's a requirement.txt file. So over here, see here I've mentioned only the ones that are important, not all the ones that my VS Code showed up, right? So these are the only ones that are required for me. Now once you have all this set, you can go to heroku.com and you will need to sign in. Since I'm already signed in, it's showing my dashboard. Now what you need to do is you need to go here and create a new app. Give it a name, say Flask app 21. It can be very general. So when you create the app, it will take you to this page. So here what you would need to do is you need to go and select GitHub here, and then you need to search for your repository. First it will ask you to connect to GitHub, but since mine's already connected, I can directly go and search for the repository that I require. So I'll be needing this one. So this, I will connect it and then I will say deploy branch, right? So it will start building this. It will start downloading all your dependencies and all of that, right? So that will take a little bit of time. So let me just jump here. So once I deploy, now here the problem is, there is one dependency that we have mentioned over here. Facial emotion recognition, the library that we're using, requires an additional library called Torch, which is very huge. Now, Heroku only admits up to 500 MB of the compressed file. So, after your branch is deployed, it will show you the amount of the compressed file. For example, I will show it to you here in activity. Yeah. So, here the process is running, right? So, all of this is already done for my app. So here it'll download all the dependencies that it requires. So if you see, all of these are KBs and in MBs, right? But there's one thing that is huge. It's 831.4 MB. So that is what's causing my push to be failed. So because Heroku doesn't allow compressed files that are greater than 500 MB. They have to be below 500 MB. But since we need Torch here, which is 800 MB, we won't be able to deploy it here. But if you're using another method or any other library, there are other libraries that you can, other OpenCV libraries that you can use to do facial emotion recognition. So if those are not as bulky as these libraries, then and if your final slug size is below 500 MB, your app will be on Heroku without any problem, right? So now I will show you an app that is. So now here I've removed the facial emotion recognition requirement and I've tried to deploy it on Heroku. So it says, so when I built it, it says the build is successful, the release phase is also successful, and I can use my app. But obviously there'll be an error because because Heroku wasn't able to download one of the main dependencies of the library. So this was just to show you guys how it will look like once your app is deployed. This is the one we started. See, it's still compressing it into a slug file, and definitely it will be greater than 500 MB because we're using Torch. But if you don't use Torch and if your slug size is less than 500 MB, it will take you to this page. When you follow this, it will take you to a new page where your app will run in the same way as it did here in the development server, right here. So that's it, guys. Happy learning.